Hi, my name is Scott Simpson, and today we'll be talking about naming compounds. So when you're going through your general chemistry textbooks, you will notice sometimes that either the chemical formula or the chemical name is given to you. We are hoping that you can learn how to decipher either the chemical name into the chemical formula or go from the formula back to the name. The reason we need to do this is so we can have common communication and know exactly what substance we are talking about. So the first thing you have to do is identify the type of bonding that's occurring in these systems. Where there are three types of bonding. There's metallic, ionic, and covalent. Where in a metallic bond, we just have metals. In ionic bonding, we have a metal paired up with a non-metal. And in covalent, we just have non-metals. So, how do we go about naming these systems? Well, first we'll talk about metallic, then we'll transition to ionic, and then we'll talk about how you name covalent compounds. So, in metallic bonds, it's just between metals. So, naming metallic compounds. You just go with the metal name. For example, you have iron solid, it's just iron. Sodium solid, sodium. So it's just as simple as that. Now let's talk about ionic compounds. Ionic compounds are a little more difficult because you just don't have one thing in them. You have a metal and a non-metal. So, you usually start with the metal's name. Followed by the non-metal's name. But for the non-metal's name, so the metal would be considered the cation. So the cation's name stays the same. The anion, or the non-metal, typically, ends in "ide." So, for example, you have oxygen, it'll change to oxide. If you have chlorine, going to change to chloride. So it sure ends in "ide." There are a few other rules that we need to keep track of. So in covalent compounds, you have suffixes that go before each of your atoms. So for example, if you have carbon monoxide, you would add M, or you'd have mono in the front. Now, in ionic compounds, the number of atoms does not matter. What does matter is the oxidation state. So the oxidation state of the metal must be specified if that metal has varying oxidation states. And typically the metals that have varying oxidation states are considered the transition metals. So those are the ones that are in the middle of the periodic table. So an example of this, if we had Fe2O3, we would call this iron 3 oxide. Now why the 3? We know each of the oxygens must have a -2 charge, so they have a total of -6. For the charges to balance out, we know that the total charge on the irons must be +6. We have 2 of the irons, so they're each +3. So we have iron 3 oxide. On the other hand, if you were to look at, let's say, one of the alkali earth metals, let's look at magnesium chloride. Now, why doesn't that have a number? Well, magnesium can only accommodate an oxidation state of +2. So we don't have to worry about adding the Roman numerals because it only has one oxidation state available to it. Now, what about covalent compounds? Covalent compounds sort of follow the same trend as ionic compounds. So, we're moving on to covalent. You typically list the less electronegative element followed by the most electronegative. En is just short for electronegative. We have to add suffixes, or excuse me, prefixes. For the number of atoms. And those prefixes, if you only have one atom, it's mono. If you have 2, it's di. If you have 3, it's tri. If you have 4, it's tetra, or tetro, depending on what sounds better, I guess. So those are the prefixes that you basically need to know. So we have an example of this. We have CO. We already talked about this. This would be carbon monoxide. Or if I can spell it properly. We have CO2. Carbon dioxide. Let's say we have this guy, PCl3. This would be phosphorus. Trichloride. And notice we still keep the "ide" like we had for the ionic compounds. And what about N2O4? This would be dinitrogen tetroxide. this case, it can be tetro or tetra. We'll just leave it with tetra. All right, but like all things in chemistry and in life, there are often exceptions to these rules. So we're going to talk about some of these exceptions. Now typically, you want to follow these naming conventions, but there are some times where this is not true. So beware of the exceptions. Some compounds have common names. For example, NH3. NH3 is actually ammonia. It's one of the ones that you'd have to memorize. And there are also polyatomic ions. And these are ions that look covalent in nature, but they have overall negative charge or positive charge on them. So for example, NH4 plus, this would be considered ammonium. OH minus, hydroxide. SO3 2 minus, sulfite. SO4 2 minus, sulfate. Now, you pretty much have to memorize the polyatomic ions, and where those come from are from your textbook or a reference table. So with that, you kind of really need to practice these a lot in order to get the naming convention rules. It's more of a memorization type information to really score well, so unfortunately you have to memorize some stuff. I'm not a huge fan of memorization, but it's what needs to be done. So hopefully you now know how to name compounds in chemistry, and hopefully go either from the chemical formula to the name, or move from the name to get to the chemical formula. If you have any questions or comments, please leave them below, and thank you for watching.